Good morning. I hope you all are doing the work assigned to you and learning whatever is being done. Okay, so this week we shall start a new chapter. So before starting, I hope you all have your class notes with you. So while explaining, I'll ask you to note down whatever is required. Other things you can just read through it and just understand the concept. Whatever is important, I'll ask you all to write. Okay. So let's start. So before we start, let's go back to our practical classes of your first PU classes. Okay, so you had two major types of experiments. One was titration and the other one was salt analysis, right? So salt analysis, what was the type of salt that you all analyzed? The type of salt you all analyzed was simple salt, right? So what is simple salt? In simple salt, you will have one acid radical and one basic radical, right? Example, NaCl, NH4Cl. All these are simple salts as they contain one acid and one basic radical, okay? So salt can be classified into simple salt, double salt, and coordination compounds or complex compounds, okay, or complex salts. So now what's a simple salt? A simple salt will contain, as I said, it will contain one acid radicals. For example, NaCl, Na plus and Cl minus. This is a simple salt. So when you put this salt in water, this will dissociate into Na plus and Cl minus ions. This is a simple salt. Okay. Moving on to double salts. Double salts are mixture of two simple salts in equimolar proportion. Okay. For example, KCl MgCl2 dot 6H2O. Okay, so this is an example of a double salt. In this, you have two different salts. One is KCl and one is MgCl2. Okay, so these salts are present in equal proportion. 1 mole of KCl and 1 mole of MgCl2 will give you this particular kind of double salt. Okay, so next, moving on to coordination compounds or complex compounds. Okay, so what are these compounds? So the name of the chapter what you're going to study will be coordination compounds. Okay. Okay, so what are these coordination compounds? So these are complex compounds. Okay, these are complex compounds in which metal atoms are bound to a number of anions or neutral molecules. Okay, so you see the structures which are given below. So this one is a general structure in which you have a metal. Okay, the central atom in a coordination compound will be a metal. Okay, and these metals will be surrounded by ligands, okay, through coordinate bond. So here M is for metals, L is for ligands. Okay, so these ligands can be anions or neutral molecules. Okay, so the number of ligands can vary. It can be 4, it can be 5, 6, 7, 8. Okay, so these complexes will have a central metal, okay, which is bound to a number of anions or neutral molecules. See, in this particular example, cobalt is a metal. Cobalt is a metal, and the neutral atom, in this case you have neutral atom NH3, okay, which is bonded to the metal. Okay, uh, and this will have a counter ion. Can you see the Cl minus outside the bracket? Okay, we'll in detail we'll learn what is this coordination compound. Okay, so this scientist Alfred Werner was the first one to formulate the structure. He was the one who gave by doing a number of experiments, he suggested the structure of coordination compounds. Okay, difference between a double salt and a complex salt. Okay, so as I said, double salt will dissociate into simple ions when you dissolve it in water. Okay, so these are the examples of a double salt: carnallite and more salt. Okay, so see the formula. So these salts, when you dissolve in water, this will dissociate. Okay, all these will dissociate and dissolve in water. Okay, whereas in case of complex compounds, so here this is one example of a complex compound, K4 FeCN6. This is an example. Okay, so you're supposed to write it like this: K4 FeCN bracket 6, close the bracket. Okay, this is how you're supposed to write. Okay, make the change. K4 FeCN6. So this is a coordination compound. Okay, so in this coordination compound, whatever is there, whatever is inside this square bracket will not dissociate if you dissolve in water. Only this part will split into K plus and this minus. This will be the positive part and this will be the negative part. Only these two will dissociate. But you won't be getting any Fe plus 2 ions or Cn minus ions. So read this. In complex compounds, complex ions such as FeCN6 4 minus of this particular complex do not dissociate into Fe plus 2 and Cn minus. Okay, you will only get K4 plus FeCN6 4 minus. Okay, so these two will be the ions which you get. You won't be getting Fe plus 2 or Cn minus. So you can learn example for this double salt. Okay, it can be asked as a 1 marker. So you can take down whatever is written in this slide. You can write down what is a coordination compound, what is given here, and maybe you can write this particular complex. It's an example. Okay, yeah, so you can note this slide, difference between double salt and complex salt. Take down these two examples. Okay, so why study coordination compounds? Okay, so before you learn something, you need to know what is the importance of learning that particular concept. Okay, is it used somewhere? So where can you find these coordination compounds? Okay, so naturally you can see the coordination compounds in chlorophyll, hemoglobin, vitamin B12. Okay, all these will have a metal ion. Okay, chlorophyll will have Mg in it. Okay, Mg plus 2 chlorophyll. This will be the central metal ion in that. Okay, then hemoglobin will have Fe as the ion. Okay, so Fe it will be in both plus 2 and plus 3 state. So the difference in these two states will help in binding and unbinding of oxygen. Okay, that's how oxygen is being transported. Okay, and then you have vitamin B12. Okay, in that CO, cobalt will be the ion in that, cobalt ion. Okay, so these are some of the naturally occurring coordination compounds. Okay, and then you can use these coordination compounds in a variety of metallurgical process. Metallurgy is nothing but extraction of metals. Okay, so after once you extract metals from their ores, you can use some of these coordination compounds to purify these metals. Okay, so in the chapter of metallurgy you will be learning a few examples, few examples how to use these coordination compounds in purifying the metal. You'll be learning that. Okay, then some coordination compounds are used as catalyst in industries. Okay, and then you can use coordination compounds as analytical reagents. Okay, maybe if you want to check the hardness of water, you can use some coordination compound. So what this coordination compound does is it binds to the ions which are present in the water. For example, if you have calcium ions in water, this particular coordination complex which you are adding, no, it gets bonded to these calcium ions. So when it bonds, it may form a precipitate. So you can use some analytical instruments to find the intensity, like the number of particles formed. So that will give you like how many number of Ca2 plus ions were present in the water sample. So as I said, it can be used as analytical reagents. Okay, and it can be used in electroplating okay, and even in textile dyeing, okay, to dye clothes, variety of colors which you find, okay. Then one more example is in medicinal chemistry, okay. So it's one complex of platinum, okay, platinum as the central metal. It is used in the treatment of cancer, okay. So this particular complex, Cl, okay. So this complex is used in the treatment of cancer. So I'll briefly explain you how this particular complex works, okay. So what is cancer? Cancer is nothing but uncontrolled cell division, right? So in cell division, there is one stage in which your DNA strand has to be unwound, right? Uh, so this particular strand of DNA has to unwind. Only then the process will continue, right? So what this complex does is it binds to the strands of DNA, okay, and this complex will not let the DNA strand to unwind, okay. So when these DNA strands cannot unwind, the cell division will be stopped. So that is how this particular complex is helping in the treatment of cancer, okay. So you can, if you're interested, you can read about it. So this platinum complex stops DNA from unwinding. That is how it's helping to reduce the number of cells, to stop division, okay. So these are some of the applications of coordination compounds, okay. Next, moving on to theories of coordination compounds, okay. So the first one is Werner's theory. So as I told you, Alfred Werner was the first one to learn about coordination compounds, okay. He conducted a number of experiments through which he could suggest the structure of coordination compound. So first we will be learning Werner's theory. We will learn his experiment and the postulates he gave after the observation of his experiment, okay. Then we will move on to VBT, valence bond theory. Third theory will be crystal field theory. So in this particular chapter, we will be discussing these three theories, okay. There are many more theories put forward. There is molecular orbital theory, but we won't be discussing all those theories here. We'll be discussing only these three theories, okay.